As we know that by using variation principle, we get homogeneous and simultaneous equations, and similarly for benzene we get those equations, homogeneous and simultaneous equations, and those equations can be written in matrix form as this is suppose I write 1 2 3 4 5 6 1 2 3 4 5 and 6, and this is 6 by 6 order matrix. Then 1 suppose this is 1 1 1 x 1 2 1 1 3 not bonded 0 1 4 not bonded 0 1 5 not bonded 0 and 1 6 is for benzene. Similarly 2 1 2 1 is 1 and bonded, 2 2 is x, 2 3 bonded, 2 4 not bonded, 2 5 not bonded and 2 6 G. 1 3 not bonded 0, 2 3 bonded, 3 3 x and 3 4 bonded, 3 5 not bonded, 3 6 not bonded. Similarly, now we take 4, 1 4 not bonded, 2 4 not bonded, 3 4 not bonded, 4 4 similar, same number, therefore it is x, and 4 5 bonded and 6 4 not bonded, and 1 5 not bonded, 2 5 not bonded, 3 5 not bonded, 4 5 bonded, 5 5 similar number, therefore x, and 5 6 bonded. 1 6 bonded in benzene, 2 6 not bonded, 3 6 not bonded, 4 6 not bonded, and 5 6 bonded, and 6 6 is similar number. So this is 6 by 6 order a matrix, and I just and second column matrix is of coefficients, that is C1, C2, C3, C4, C5 and C6. And if these two matrices are multiplied, then we get null matrix 0 0 0 0 0 and 0. So in this we get if multiplication of these two matrices is 0, then definitely one of matrix must be 0. But C1, C2, C3, this is the column matrix of coefficient, so it cannot be 0. So definitely this 6 by 6 order matrix must be 0. Otherwise, if it is 0, it gives a trivial equation, a trivial solution. So this is 0. So then we write down in that. Now we take in matrix form x1 0 0 0. Since it is a square matrix, so it can be written in determinant form x1 triple 0 1 and 1 x 1 0 0 0 0 1 x 1 0 0 0 0 0 x1 0 and um, triple zero triple zero 1 x 1 and 1 triple zero 1 x. This is let me check. C1, C2, C3, C4, C5 and C6. So जीरो जीरो यहाँ पर है x1 triple zero 1 1 x1 triple zero 0 1 x 1 0 0 and 0 0 यहाँ पर ही गलत 0 0 1 x 1 0 0 0 1 x 1 0 and triple zero 1 x 1 and 1 double 0 1 triple 0 1 x and this is 1 triple 0 1 x. So here again I correct that 1 triple 0 1 triple 0 1 x triple 0 1 x 1 and here it is 1 x 1 and 0 1 x 1 0 0 1 x 1 triple 0 and x 1 0 x 1 0 triple 0 1. Now if we multiply we get circular equations and these are C1 xc1 xc1 plus C2 plus 0 plus C6. Directly I am writing that C6 is equal to 0 and next is C1 plus xc2 plus C3 is equal to 0 and next is C1 C2 plus xc3 plus C4 is equal to 0. This is equation number 1, this is equation number 2, this is equation number 3 and C3 plus xc4 plus C5 is equal to 0. This is equation number 4 and this is C4 plus xc5 plus C6 is equal to 0. This is equation number 5 and we get that C1 plus C5 plus xc6 बराबर 0. This is 6. As we know that we get these molecular orbitals after linear combination of pi atomic orbitals. Then we take one by one the values of root x, the value of x, and already we have done that x बराबर -2, x बराबर -1 and -1. Two values we get x बराबर 2 and x minus x बराबर प्लस 1 and 1, 1 and 1 and x बराबर 2. तो one by one we take that for x बराबर minus 2. These we get these secular equations. Then suppose we are taking for x बराबर 2, for x बराबर minus 2, and this is x बराबर minus 2, this is alpha plus 2 beta, bonding orbital, this is bonding orbital, bonding molecular orbital, and to find phi 1 जिसमें which is having 2 electrons. So if we write 2 minus 2 in place of x, then I simply write here only my x बराबर, if I keep x बराबर minus 2, then it is minus 2c1, c2 c6, and c1 is minus 2c2, and here x is minus 2c3, here it is minus 2c4 minus 2c5 and minus 2c6, minus 2c6. So we start the for molecular orbitals that add equation 1 and 2. On adding equation 1 and 2, what we get on addition, not 1 and 2, equation 2 and 3, on adding equation 2 and 3, what we get, C1 minus 2C2 plus C3 plus C2 minus 2C3 plus C4 is equal to 0. Then we get C1 minus minus C2 minus C3 plus C4, this is equal to 0. Say this equation is number 7. And similarly, on adding on adding 3 and 4, on adding equation 3 and 4, what we get, C2 minus 2C3 plus C4 plus C3 minus 2C4 minus 2C4 plus C5 is equal to 0. Then we get C2 minus C3 minus C4 plus C5 is equal to 0. That this is equation number 8 and this is equation number 7. So this is equation number 7 and this is equation number 8. Now on adding equation 7 and 8, then what we get? C1 minus 2C2 plus C3 plus C2. No. C1 minus C2 minus C3 plus C4 plus C2 minus C3 minus C4 plus C5 is equal to 0. Then C2 से C2 कैंसिल हो गया and C4 से C4 is cancelled. Then we get C1 minus 2C3 plus C5 is equal to 0 and we can say C1 plus C5 is equal to 2C3. This is the value we got. If we keep this value in equation number 6, keep this key on putting C1 plus C5 is equal to 2C3 in equation number 6. I think I will not write this. Then C1 plus, on putting C1 plus C5, then we get C1 2C3 minus 2C6 is equal to 0. Therefore, C3 is equal to C6. If we keep this value C6 in equation number this is minus 2C2. So keeping this value in equation number 6, putting this value, putting C3 is equal to C6 in equation number 1. Then what we get? Minus 2C1 plus C2 plus C3 minus 2C1 plus C2 plus C3, and we can add this equation and add two and add equation 2, we get अभी भी आ रहा है ना वैसे ही, नहीं तो आगे करें? नहीं चल रहा है, चल रहा है, करूँ? तो this is, and add equation 2 we get, what equation is minus 2C1 minus 2C1 plus C2 plus C3 minus C3 बराबर C6 in equation 1, and if we get in this, तो add equation 1 and add equation 2. Then what we get? Let's see. C1 minus 2C2 uh, plus C3, and this is, and minus 2C1, this is equation 2, and this is minus 2C1 plus C2 C3 we get in equation 1, and add equation 2 we get and minus 2C1 put in equation 1 minus 2C1 plus C2 plus C3 and add equation 2 in it. We get C1 minus C2 plus C3 and minus 2C1 plus C2 plus C3. This is minus 2C2. Minus 2C2 add in C2. Then C1 minus 2C2 plus C3 minus 2C1 plus C2 plus C3 बराबर 0. C1 and minus 2C1, this is minus C1 and 2C1 minus C2, and this is something wrong. C2 C3 minus C3 बराबर C6 in equation 1. Then we get 2 minus 2C1 plus C2 in equation 2. 2 minus 2C1 and plus C2 plus 3 and subtract equation 2 from it. We subtracting this from, so subtract from and subtract it from equation 2. Then you get C1 minus 2C2 plus C3 minus minus 2C1 plus C2 and plus C3. This is equal to 0. C1 minus 2C2 plus C3 plus 2C1 minus C2 minus C3 is equal to 0. This is cancelled, and C1 and 2C1, 3C1 is 3C1 minus 3C2 is equal to 0. Therefore, 3C1 is equal to 3C2. Therefore, C2 is equal to C1. So, that one relationship we have got in terms of C2 in terms of C1. Now we can and one relationship we got that C3 C6 is equal to C3. This is second relation. When we get to C2 barabar C1, then we keep this value. Keep putting C2 barabar C1 in equation number 1. In equation number or C6 C3 we go no, then minus 2C1 minus 2C1 plus C1 plus C1 plus C6 is equal to 0. No, minus 2C1 plus C1 plus, therefore minus C1 is equal to minus C6, therefore C6 is equal to C1. This is another relationship which we got, that C6 barabar C1, C6 barabar C1, and that C6 barabar C3 also, then C1 barabar C3 also. So we got that C2 barabar C1, C3 barabar C1 and C6 barabar C1. Now left with C4 and C5. So we can keep in this C2 is equal to C1 minus C3 is equal to 2C1 plus C4 is equal to 0. Therefore, minus C1 plus C4 is equal to 0. Minus C1 is equal to minus C4. Therefore, C1 is equal to C4. So, this again we got C4 in terms of C1. And finally, we get this, putting C4 and barabar 1 and C6 barabar 1 in equation 5. Then we get C1 minus 2C5 plus C1 is equal to 0, or 2C1 minus 2C5 barabar 0. Therefore, 2C1 is equal to 2C5. Therefore, C1 is equal to C5. This is another relationship which is we have got in terms of the C5 is equal to C1. Now we have calculated all the coefficients for molecular orbital phi 1. This is phi 1 is linear combination of 6 atomic orbitals. 6 pi atomic orbitals. So we can write down for x barabar minus 2, for x barabar minus 2, we get phi 1 is equal to C1 F1 plus C2 F2 plus C3 F3 plus C4 F4 plus C5 F5 and plus C6 F6. This is the linear combination of atomic orbitals. And now definitely we have gone through that C1 barabar C2 barabar C3 बराबर C4 बराबर C5 is equal to C6. My God. So I have got that V5 phi1 can be written as C1 F1 plus F2 plus F3 plus F4 plus F5 plus F6. Now apply the condition of normalization. Apply condition of normalization. Condition of normalization. That is C1 square plus C2 square plus C3 square plus C4 square plus C5 square plus C6 square is equal to 1. Therefore, all is 1, 2, 3, 4, 5, 6. Therefore, 6C1 square is equal to 1. Therefore, C1 is equal to 1 by under root 6. So, we get that phi1 is equal to 1 by root 6 F1 plus F2 plus F3 plus F4 plus F5 and F6, where this F1, F2 are the atomic orbitals, and this is phi 6, phi 1 is bonding molecular orbital. So we have completed first for x barabar -2, and this is bonding molecular orbital. This is phi 1. So yesterday we got these circular equations, and now we keep the value of -1. Earlier I told you that we get two roots where the values is -1. These two roots we get in the form x values in -1. So 2 times we get x barabar -1. So this is the case of degenerate, and we get two energy levels, phi 2 and phi 3, and these are bonding molecular orbitals, and both these two molecular orbitals contain two electrons. So first we calculate for molecular orbital phi 2. So if we put the value of x is equal to -1 in these circular equations from 1 to 6, then we get minus C1 plus C2 plus C6 plus C6 is equal to 0. C2 C1 minus C2 plus C3 is equal to 0. C2 minus C3 plus C4 is equal to 0. This is equation 1, 2, 3 and C3 minus C4 plus C5 is equal to 0. See equation number 4. And C4 minus C5 plus C6 is equal to 0. This is equation number 5. And C1 plus C5 and minus C6 is equal to 0. This is equation number 6. We get in this form. So now I rub this. Now now add 1 and 2. On adding 1 and 2, equation number 1 and 2, we get C2 cancel, C1 cancel, we get C6. C6 is equal to minus C3. And if we get 2 and 3 on adding at equation 2 and 3, we get C3 cancel, C2 cancel, C1 is C4 is equal to minus C1, and if we add 4 and 5, then we get C4 cancel, C3, C6 on adding 4 and 5, we get that C5 cancel, C4 cancel, C3, that C6 is equal to minus C3. So we keep these values here, that C6 is equal to minus C3, C4 is equal to minus C5, and if we get 4 and 5 or we get 3 and 4, on adding 3 and 4, then 3 and 4 means C4, C4 cancel, C3, C3 cancel, we get C5 is equal to minus C2. So C6 is equal to minus C3, and C4 is equal to minus C1, and C5 is equal to minus C2. So this we can rub. Now if we keep this values C3, C1 and C2, we have reduced these 6 variables in terms of these 3 variables. So we can write down that minus C1 plus C2 plus C6 can be written as that minus C1 plus C2 and C6 is minus C3, and if we take common negative sign, take negative sign common, then C1 plus C1, and this is minus C2 plus C3 is equation number 1. C1 minus C2 plus C3 is in the same form, C1 minus C2 plus C3, this is equation number 2. C2 minus C3 plus C4. Now we have that C1 is equal to C4 minus C1, and minus C3 is minus C3 and C2. Then we get C2. See this equation number 3. C2 minus C3. C2 minus C3, and we can write that minus C1, and again take negative sign, common minus, then we get C1 minus C2 and plus C3. This is equation number 3, and now we can rub this and take see this equation number 4, C3 minus C4. Then C3 minus C4 can be written as C1 plus C1, and C5 is equal to minus C2. This is equation number, and it is that C1 minus C2 plus C3. This is equation number 4, and C4 minus C5 plus C6. C4 we can write down minus C1, C5 minus C5 plus C2, and plus C6 is minus C3. This is again minus sign common, then we can write down it C1 plus C2, C1 minus C2 plus C3. This is equation number 5. Negative and this is equation number 5, and last C1 plus C5 is minus C2, and minus C6 is equal to plus C3. This is equation number 6. So thus we see that we have reduced all 6 secular equations in one single equation, and that is C1 minus C2 plus C3. This we got this equation, but we can't solve this equation having 3 variables, and we have also calculate for 2 molecular orbitals for degenerate case. So it is, we can assume arbitrarily one coefficient as 0. So for simplification, for simplicity, we take C1 is equal to 0. Simplest case is if we consider that C1 is equal to 0, assume. We have assumed that C1 is equal to 0. So we rub this because we have got this equation C1 minus C2 plus C3. So in this equation we are having 3 variables, but equation is 1, so we are taking C1 is equal to 0. In calculation of molecular orbitals, we are taking that C1 is equal to 0. Now if we see this C1 minus C2 barabar 0, it means from here, this is, say this is equation number 7. Because we have assume that C1 is equal to 0, then we will take all other variables in terms of C2. Then we get 0 from here, from equation 7. From equation 7, minus C2 is equal to 0 minus C2, C3. C3 is equal to C2. In terms of C3, C3 is equal to C2. Now this C3 is C2, and if we keep this value in minus C1 plus C2 plus C6 is equal to 0. Then minus C1 is 0 and C2 is equal to minus C6. Or C6 is equal to minus C2. And C3 is in terms of C2, C6 is in terms of C2, and if we for C4 we can take that C2 minus C4 plus C3 is equal to 0. Then we get C3 is equal to C2. For C4 we can take that C1 minus C2 plus let me check this. C1 minus C2 plus C3 barabar 0. This is equation number 7, and C3 is equal to C2. Now if we keep it in equation number 1, put C3 is equal to C2 in equation 1. Then what we get? Equation 1 is minus C1 plus C2 and minus C3 is equal to 0. C6th, then minus C1 is 0, therefore C2 is equal to C3. So we get C3 is equal to C2. We got C3 in terms of C2. Now for C4 we take value C2 and minus C3 plus C4 is equal to 0. C3 minus C2 plus C4 is equal to 0. So we get that C1 and barabar C4 is equal to 0. From here we get value of C4 is equal to 0. This is from equation number 3. And put C3 बराबर C2 in equation 3. Then you get C1 बराबर C4 is equal to 0. Then we get C3 in terms of C2 and C3 and C3 बराबर C2 again here from here. So we can cancel this and C3 is equal to C2, C4 is equal to minus C1 is equal to 0. So C4 is equal to 0 and we can take that C4 minus C5 plus C6 is equal to 0. So C4 is 0 but and minus C5 is equal to plus C2. Here we can write plus C2 and plus C6 is equal to 0. Therefore, C6 is equal to minus C2. We get C4 0 and C6 is minus C2. Now the left is C5 is already there in terms of C2. Then we can write C5 is equal to minus C2. C3, C4, C5, C6, C1 is 0 and we have taken all the variables in terms of C2. So we know that phi 2 is linear combination of 6 atomic orbitals. So we can write down that phi 2 is equal to C1 F1 plus C2 F2 plus C3 F3 plus C4 F4 plus C5 F5 plus C6 F6. So here C1 is 0 plus C2 F2. C2 is equal to C3. So plus C2 F2 plus 0 plus C5 is equal to minus C2. Therefore, it is minus C2 F5 plus this is minus C6 is equal to minus C2. Therefore, minus C2 F6. So we can phi 2 is equal to C2 F2, here it is F3, C2 F2 plus F3 minus F4, minus F4 is 0, this is minus F5 and minus F6. Now we have to calculate the value of C2 coefficient, and if we apply the normalization condition, by applying normalization condition, normalization, condition, we know that C1 square plus C2 square plus C3 square plus C4 square plus C1 C5 square plus C6 is equal to 1. Though I have explained in earlier videos, still I will like to explain this how this comes. You know that phi 2 normalization condition is phi 2 d square d tau is equal to 1. If we write down that only for these that this C2 F2 plus C3 F3 minus C5 F5 minus C6 F6 d tau is equal to 1. Definitely C2 square, यहाँ से if we get multiplied by same C2 F2 plus C3 F3 minus C5 F5 minus C6 F6 and d tau. We say d tau is equal to 1. So see this C2 square F2 square C2 square F2 square d tau. You will get C2 C3 will be orthogonal, will be 0. C2 C5 will be again orthogonal to 0 and C2 C6 will also 0. Now second case is C3 with C2 is 0. C3 square, so we take C3 square and we get inside F3 square and d tau. And C3, C5, C6 again 0. C5 square we get plus C5 square and F5 square d tau. Similarly, we get C6 square d tau, CF6, and this is F5 square, this is one normalized because wave functions are normalized also. So this is equal to 1, F2 square d tau is equal to 1, 1, 1. So we get that C2 square plus C3 square plus C5 square plus C6 square is equal to 1. So in this case we get C1 is 0 and C4 is 0. So we get C2 square plus C3 square plus C5 square plus C6 square is equal to 1. If we rewrite in terms of then C2 is equal to C3 square, C4 is 0, C5 is plus CY square plus CX square. So C2 square plus C2 square plus C2 square plus C2 square is equal to 1. So 1, 2, 3, 4. Therefore, we get 4, that 4 C2 square is equal to 1. Therefore, C2 is equal to 1 by 2. So here we get the value of phi 2, C2 is equal to, that phi 2 is equal to 1 by 2 F2 plus F3 minus F5 and minus F6. This is molecular orbital number 2. Now we take the molecular orbital F phi 3. So this will be the same case, phi 3, and this will be E3, x barabar minus 1 and having 2 electrons. This is the case of degeneracy. So in one molecular orbital we have taken that C1 is equal to 0. Now for second degenerate case we can not repeat the value of C1 is equal to 0. We cannot arbitrarily take the value of one coefficient equal to 0. So in this case we apply the condition of orthogonality. So we know that every atomic orbital or molecular orbitals are orthogonal to each other. So if we take that orthogonality condition, then phi 2 and phi 3 d tau should be equal to 0. So we will take first, but we have to calculate these coefficients. So here we know that it is phi 2 is 1 by 2 phi 2 1 by 2 that was C2 F2 plus C2 F3 so we take F2 F3 minus F5 and minus F6 and this is C1 F1 plus C2 F2 plus C3 F3 plus C4 F4 plus C5 F5 plus C6 S6 F6 d tau is equal to 0. So we can take this constant 1 by 2 outside. So it is like this. If we multiply by 2 on both sides, then we cancel this. On multiplication, this is on multiplication by 2 on both sides, multiply by 2 on both sides. So 1 by 2 is cancelled in above equation. So if we multiply this, then this is cancelled. Then see, here we will give C1 F1 F2 0. Here F2 F2, yes. So here you get C2 F2 square d tau plus F2 C3 orthogonal 0, F2 F4 orthogonal, F2 F5 orthogonal, F2 F6 orthogonal, so 0. Now next is F3. F3 F1 orthogonal 0, F3 F2 orthogonal 0, F3 and C3 F3. So you get C3 F3 square into d tau plus अब C1 F5 F1 orthogonal 0, F5 F2 orthogonal 0, F3 F5 orthogonal, F4 F5 orthogonal, C5 F5. So here you get C5 F5 square d tau plus similarly you get F6 C6 F6 square d tau. This is equal to 0. This is the condition of orthogonality. So I now rub this. This is one normalized condition है. This is all normalized, so we get from here one relation C2 plus C3. Over here it will you get minus C5 because it was and here also you will get minus C6. So C2 plus C3 minus C5 and minus C6 is equal to 0. Here you get one relationship, and so C2 plus C3 is equal to C5 plus C6. Say this is equation number 8. And equation number 7 was a relationship that C1 plus C2 is C3. No, sorry. C1 plus C3. C1 minus C2 plus C3 is 0. Therefore, C1 plus C3 is equal to C2. This is equation number 7. So we got this relation, and if we add all these secularized equations, that minus C1 plus C2 plus C6 बराबर 0 and C1 minus C2 plus C3 is equal to 0 and C2 minus C3 plus C4 is equal to 0 and C3 minus C4 plus C5 is equal to 0 and C4 minus C5 plus C6 is equal to 0 and C1 plus C5 and minus C6 is equal to 0. If we add all these 6 equations, then we get C1 plus C2 plus C3 plus C4 plus C5 plus C6 is equal to 0. Minus C1 cancel, C2 cancel, and in this way we will get C1 plus C2 plus C3 plus C4 plus C5 plus C6 is equal to 0. And one relationship is we are having C1 plus C3 is equal to C2. So here we can write down C2, C1, put C2 is equal to C1 plus C3 in equation 9. In equation 9, what you get? C1 plus C1 plus C3 plus C3 plus C4 plus C5 plus C6 is equal to 0, or you get C4, we can write down it, C4 can be written as minus C1. So C1 cancel, so we get C1, no I can. So we get that C1 plus 2C3 plus C5 plus C6 is equal to 0, and that C1 plus 2C3 is equal to minus C5 and minus C6. from here you are getting C2 plus C3, and here also you can write down C2 is equal to C1 plus C3 plus C3 is equal to C5 plus C6. Therefore, C1 plus 2C3 is equal to C5 plus C6. Say this is equation number 10 and this is equation number 11. Now add equation number 10 and 11. Add equation number 10 and 11. So what you get? C1 plus 2C3 is equal to minus C5 minus C6, and C1 plus 2C3 is equal to C5 plus C6. Therefore, this is cancelled. So you get that 2C1 plus 4C3 is equal to 0. Therefore, C3 is equal to minus half C1. This is one relationship we got, that C3 is equal to minus half C1. Now we will take all the coefficients C1, C2, C3, C4, C5, C6 in terms of C1. So we got C3 is from relationship this, from the, we know that C1 plus C3 is equal to C2, and C3 is equal to minus half C1, then C1 minus half C1 is equal to C2. Therefore, C2 is equal to half C1. So again, second coefficient in terms of C2 is equal to half C1. C2, C1, C2, C3, and we know that C4 is in terms of is equal to minus C1. This is already in terms of C1, and C3, C2, C4 we have got. If we take equation number 4. Equation number 4 is C3 minus C4 plus C5 is equal to 0, because here in minus x minus C4. So from here we get C3 is minus half C1 and minus C1 is plus C5 is equal to 0. Therefore, this is minus C4, so it is C1. Minus C4 is equal to minus C1, therefore, so this is C5 is equal to minus half C1, half C1, and next when this is on other side, goes on other side, this is C5 is equal to minus half C1. And if we take C6, so we can take minus C1 plus C2 plus C6 is equal to 0, minus C1 and plus C2 is equal to half C1 plus half C1 plus C6 is equal to 0. So you get that minus half C1 minus C1 plus C2 plus C6 plus C2 is equal to half C1. Half C1 minus half C1 is equal to C plus C6 is equal to 0. Therefore, C6 is equal to half C1. So we get all the coefficients. We get all the coefficients in terms of this is plus half C1. Now we have got all the coefficients in terms of C1. For the third molecular orbital, so we can write down that phi 3 is equal to C1 F1 plus C2 F2 plus C3 F3 plus C4 F4 plus C5 F5 plus C6 F6. C1 F1 plus C2 F2 की जगह in place of C2 half C1 plus half C1 F2. C3 is minus half. This is minus half C2 F3 plus C4. So it will be minus C1 minus C1 F4 plus C5 is minus half C1 minus half C1 F5 plus half C6 C1 F6. So take phi 3 phi 3 will be C1 common, you get this is F1 plus half F2 minus this is C1 minus half F3 minus F4 minus half F5 plus half F6. So this is phi 3 molecular orbital, and if for value of C1 we apply the condition of normalization. So you get here C1 square plus 1 by 4 C1 square plus 1 by 4 C1 square plus C1 square plus 1 by 4 C1 square plus 1 by 4 C1 square. So this we get that this is phi 3 and phi this is for coefficient normalization condition, this is should be equal to 1. Therefore 1 and 1 2 and 1 by 4 half, 1 by 4 half. So we get 3C1 square is equal to 1. Therefore C1 is equal to 1 by root 3. So we get the value of C1 is equal to 1 by 3. So here we get phi 3 is equal to 1 by root 3 and F1 plus half F2 minus half F3 minus F4 minus half F5 plus half F6. This is phi 3 bonding molecular orbital. So we have uh, got expressions for phi 1, phi 2 and phi 3.